Today we're going to talk about quadratic functions or parabolas. So this is section 2.3 in your book and on MyMathLab. So we spent some time talking about linear functions, and so we're just going to kind of progressively get a little more involved with functions as we go. So we started off with the simplest kind of function we can have, which is pretty much a linear function. And now we're going to move on to kind of a little more challenging type function. So quadratic functions are x-squared equations. Generally speaking, we will have them in the form of ax squared plus bx plus c, where a, b, and c are real numbers. Okay, we've already looked at this form on the review day where we looked at factoring and stuff like that. But we're going to talk about that, but we're going to focus more on the components of a parabola. Okay, because graphs of quadratic functions always end up being parabolas. So rather than give you a whole bunch of definitions of the components, I just want you to sketch a parabola real fast. I'm going to purposely not make it centered. So draw a parabola that is not just perfectly centered. So rather than giving you definitions of all these, I'm just going to kind of eyeball and pinpoint what they are. The turning point of the parabola is called the vertex. We're going to talk about how to find that, how to identify it here in a minute, but for now I just want you to know kind of what it is. The point where it crosses the y-axis, we've already talked about this with lines. What's that called? The point where it crosses the y-axis? The y-intercept? Okay, there'll only ever be one y-intercept if it's a function, remember? Because if there were two y-intercepts, it would fail the vertical line test. Okay, and then in this case, there are two x-intercepts. So I'm going to do this and just draw some kind of arrows here. There's one there and one there. And then there's also kind of an imaginary line of symmetry that cuts the parabola in half, and it's called the axis of symmetry. What do you notice about the axis of symmetry? What point is it always going to go through because it's going through the middle? Always going to go through the vertex. So we're going to talk about how those are related also. So we're going to talk about how to find these, but not just graphically, but how to take an equation and figure out what these things would be. So how do you find the x-intercepts? How do you find the y-intercept? How do you find the vertex? All that stuff. Okay, so let's kind of break down the x-squared equation. So the first thing is, if a is greater than 0, and by a I mean the number in front of x squared, right? Ax squared plus bx plus c. So if a is positive, then the parabola opens upward. In other words, it looks just like the one we drew above. Okay, it's a curve that opens upward. But if a is negative, so if the number in front of x squared is negative, then the parabola is upside down or opens downward. So when we're trying to come up with a graph from the equation, that's one thing that is helpful for us to know. The next thing is how to find intercepts. I believe we already did this with linear equations. I'm not sure though. So to find x-intercepts, we need to set y equal to 0. Pretty sure we did that with lines. And then to find the y-intercept, notice x-intercept is possibly plural, y-intercept is not. For the reason I just mentioned, it wouldn't be a function if it had more than one y-intercept. So a good rule of thumb is if you want to find the intercept or the intercepts, if you set the other variable equal to 0. If you want the x-intercept, set the y equal to 0. If you want the y-intercept, set the x equal to 0. Okay, so let's talk about how we find the vertex. Okay, and so there's two kind of mainstream ways to find the vertex, and we're going to briefly discuss them both. So if the equation looks like the following, so sometimes you're going to get a function that looks like this, okay, where A, H, and K are just numbers. This is actually called vertex form because it actually gives you the vertex. All right, so notice that if it's in this form, it's still squared, so we know it's a parabola, okay? But you just pull the numbers out. So notice the change here, though. This has a minus sign, okay? So I'm going to give a little note here. You're going to change the sign of H, but not K. And the reason you change the sign of H is because there's a minus in the formula. I can't write today. That was supposed to say not K. Okay, so this is called vertex form for the reason that you can pull the vertex out without really having to do any work. But most often the equation is going to look like what we're used to, which is the ax squared plus bx plus c. So if the equation looks like our standard, which is going to be most common, then the formula to find the vertex looks like this. If the x value of the vertex will be negative b over 2a, and the y part of the vertex will be f of negative b over 2a. Okay? Don't make that harder than it is. This just means plug in the x you just got. So you find the x value by doing negative b over 2a, and then you find its partner y by just plugging in that x. Okay, so we're going to run through some examples where we find these major components to a parabola, and then maybe we can apply that and go ahead and sketch a graph. So I want you to find the intercepts, the vertex, the max or the min, and then I want you to graph. So your questions like this on MyMathLab will be literally structured like this. Like it'll be like, find the intercepts, and you'll input those, and it'll say, you know, either good job or you need to work on this some more. And then it'll ask you for the vertex. So it has different parts. Okay? And remember what I said about MyMathLab, you actually can get partial credit. So if you were to get the intercepts and the vertex right, but your graph wasn't quite right, then you would get partial credit for that question. You could still always try another one, though, if you want to get full credit. So remember, you can always choose similar exercise or something of that wording, or give me another problem like this. I can't remember what the exact wording for it is. All right, so first thing is, let's just make the observation that we know it's going to open upward. How? Well, not the x, but the number in front of x squared, yes. Okay, the number in front of x squared is positive because, by the way, it's not there, right? And it's understood to be what when there's no number in front? 1, so it's a positive 1. All right, so let's just kind of run through the list. So we'll find the x-intercept first. Remember, we always set y equal to 0 for that. So we've got 0 equals x squared minus 4x plus 4. So notice here is where your factoring skills have to come in, and that's why we reviewed it the very first week. Okay? We don't really need full-blown AC method for this because the coefficient in front of x squared is just 1. So I'm going to kind of quickly factor this, and if you need a little bit more practice on that, then you need to kind of work that on your own. So I expect that you can factor pretty quickly, especially in this section. So what are the factors of 4 that add up to negative 4? It'd be minus 2 and what? Minus 2, right? It'd have to be negative because negative 2 times negative 2 is 4, but if you add them, you get negative 4. So then notice we only have one kind of unique parentheses to set equal to 0. So we end up getting x equals 2. My math lab is probably going to want you to enter this as a point. So it's the point 2 comma 0. Okay, so that's x-intercept. Now let's find y-intercept. Y-intercept is easier because you don't have to worry about factoring. So if we set x equal to 0, we're going to get f of 0 equals 0 squared minus 4 times 0 plus 4. So what are we going to be left with? 4. So y equals 4, or again, if you're asked to list it as a point, it would be 0 comma 4. Okay, so now let's look at the vertex. Okay, so I'm going to rewrite the function down here just to kind of make a point. Notice it's not in vertex form. Okay, it doesn't look like that first example that I gave you for vertex. Okay, I'm going to move this in a minute. It does not look like this. It's not a parentheses with a number added at the end. Okay, it looks like our just regular old vanilla general form for an x squared equation, which means we have to use our vertex formula. So what's our vertex formula? Negative b over what? 2a. Okay, so what's negative b if b is already negative 4? Positive 4, right? So it's 4 over 2 times 1, or 2. So that's only half the vertex. I almost always have students be like, oh, the vertex is 2, and they move along. Okay, but remember, the vertex is a point, so it has to have an x part and also a what? A y part. So now we want to find the y partner to that. You might notice that you might already know it, but let's go ahead and find it anyway. So 2 squared minus 4 times 2 plus 4. So if we do exponents first, we're going to get 4 minus 8 plus 4, which is just what? 0, right? So notice we end up getting a vertex of 2, 0. But what do you notice about that point? Yeah, like we already had it, but we still would need to figure it out if my math lab was asking you for all the components. Okay, so let's see if we can put all this together, and then we'll talk about whether we have a max or a min. I like to graph it and then discuss the max or the min. So we have a x-intercept here. We have a y-intercept here. We know the parabola opens up, and we know that this is also the vertex. Okay, so one thing is, notice we don't have that much information here. We don't have that many points, but I think the fact that we have the vertex is probably enough to know what the graph would be. So we know that it's going to curve up this way, and then because it's the vertex, we know it's got to make a turn there. Okay, your bottom does need to be curved. It doesn't need to look like a V. It needs to look more like a U. It's a little misleading. I think mine's a little sharper than I really meant it to be. So by the way, now that we're looking at this, I think we can see that there is no max, right? But what do we have? We have a min, and so here's how you'll enter that in most of the time. You'll say that we have a minimum at 0, okay? Or maybe the point 2, 0. But a lot of times when they ask you for max or min, they'll just want the location of where that, or sorry, not the location, but how high up it goes, right? And the lowest point is at 0. Okay, so with a parabola, will you ever have both a max and a min? You won't, right? You'll have one or the other. If it's an opening upward parabola, you'll have a min, and then if it's an opening downward parabola, you'll have a max. Okay. All right, so let's do one where maybe we don't graph it, but where we just find the pieces, because maybe our pieces aren't going to be so pleasant. So you'll just need to play around with my math lab. Sometimes it will have you actually like graph yourself, where you'll use your mouse to like click points where you want them. And then sometimes it'll give you a choice of a bunch of graphs, and you just have to pick the one that's correct. It just depends on how the question is worded. All right, so let's look at this function. So this one's going to be a little tougher. So why do I say this is going to be a little tougher? Yeah, A is negative, and we have large numbers. So right off the bat, this one looks a little tougher than the one that we just did, right? So the first thing is, let's notice that we know it's going to open downward, which looking ahead, that means we're going to have what instead of a min? We're going to have a max, okay? All right, so let's just run through our options. So I can find the x-intercept by setting y equal to 0. So I could factor out that negative sign so that I was trying to work with something positive, but I would say that we would probably go to AC method here. Sorry, not AC method, but quadratic formula here. Because remember, we're going to try to factor, and if factoring seems too difficult, then we're going to jump to what? Quadratic formula. So this one does actually factor once you factor out the negative sign. But I'm not really going to mess with that, and to be honest, I think we need more practice with quadratic formula anyway. So quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember that one of the benefits to quadratic formula is it always works. Okay? It might be a little long, it might be a little tedious, but it always works. So that's one of the reasons why, even though it's a longer formula, I like it and I use it pretty regularly. All right, so let's just go slow since we have bigger numbers, but it's negative b, so what's that going to be? Negative 16 plus or minus the square root of b squared or 16 squared minus 4 times a, which is negative 4, times c, which is negative 15, and then all of that over 2a. So don't get intimidated by the fact that these are a little bit bigger numbers than we practiced the first week. Okay, it's still just quadratic formula, and I promise we can do it. So this is going to be negative 16 plus or minus 16 squared is 256. Be really, really careful of your signs, but negative 4 times negative 4 is 16, and then times negative 15 would be negative 240. And then on the bottom, we're going to get negative 8. So even though we have large numbers, actually 256 take away 240 is the square root of 16. And we actually know the square root of 16, right? We don't need to factor tree that or do anything fancy with it, right? What is the square root of 16? 4. So we end up getting negative 16 plus or minus 4 over negative 8. So we did one like this last week, but remember you need to pull this apart into two pieces. So it's negative 16 plus 4 over the denominator, but it's also negative 16 minus 4 over the denominator. And then just simplify what you have. So I'm going to get negative 12 over negative 8, okay? And that reduces to 3 over 2. So use your calculator with the math fraction key to reduce fractions if you want. So negative 12 over negative 8 reduces to 3/2. This one is going to give us negative 20 over negative 8, which reduces to 5/2. Okay, so there's the x-intercepts. So if they're going to be listed as points, it's going to be 3/2, comma 0, and 5/2, comma 0. In other words, they're trying to tell you that it crosses the x-axis how many times? Twice. Okay. By the way, don't overthink those. What's 3.5 if you were trying to graph it? I'm not going to make you do this one. 1.5, right? And then 5 over 2 is 2.5, right? You can always figure out what fractions are in decimal form by just dividing on your calculator. Okay, so just 3 divided by 2 or 5 divided by 2. Okay. Okay, so that's x-intercept. So let's do y-intercept. X-intercepts are usually the most time-consuming parts. The y-intercept comparatively is usually super fast. So we're going to set x equal to 0, right? So we get negative 4 times 0 squared plus 16 times 0 minus 15. So we end up getting negative 15, or the point 0, negative 15. Okay, so what about the vertex? Okay, so again, I'm going to rewrite the equation just because it's not really on screen anymore, or it's not about to be anyway. So notice this is not vertex form. Okay, so I just need to use my formula. And what's my formula for x again? negative b over 2a. So negative b is negative 16, right, over 2 times a. So I'm going to get negative 16 over negative 8, which, what does that reduce to? 2. Okay, so that's not my final answer for a vertex. It's only half of it, right? I still need its y partner. And you always find the y by just plugging in the x. So let's figure out what g of 2 is. So it's negative 4 times 2 squared plus 16 times 2 minus 15. Okay, make sure you do your order of operations. It's going to be really, really important. But you could use a calculator here. But you would do 2 squared first, right? So that would be 4. So you'd end up getting negative 16 for the first term, 32 for the second term, and then minus 15. So it actually works out to be somewhat nice. It's 1. So the vertex then, I want you to write it as a point as x comma y. So the vertex is 2, 1. So we already talked about this, but there's no min, right? And then the max is 1 or the point 2, 1. Oftentimes when you're asked to find the max or the min, all they're wanting is how tall it is or like what the y is. Okay, so that's why I listed that, but sometimes you might want the point as well. So if you know the vertex, you kind of get the max and the min for free. How come? Yeah, depending on whether it opens upward or downward, like the vertex is going to be the max or the min, okay? Just as we discussed earlier, we won't have both, okay? So to find the max or the min, we just want to look at the vertex. Okay, I don't remember if this is on your homework this time, but just in case it is, note the vertex will also tell us what the axis of symmetry is. Okay, the axis of symmetry is always going to be a vertical line, and it's always going to cross through that vertex. So the axis of symmetry will always be x equals the x value of the vertex. So the axis of symmetry in the example we just finished would be x equals 2. Okay, so it's just x equals and then go pull the x value from the vertex itself. Okay, so I don't want to spend too much time on that because, to be honest, if you have the vertex, you have really what you need, okay, to find max or min or the axis of symmetry. Okay, so let's look at one that might give us maybe even more unusual answers. But this one we're actually going to graph. So notice I added in something there. I asked you to find the range. But we'll be able to find the range if we can just get a good graph. Okay, so that shouldn't be too hard. All right, so I guess I probably should give you the function, right? That would be helpful. So x squared minus 8x plus 12. Okay, actually this one's actually not so bad. I was thinking of the other one. This one's actually going to come out nice. Sorry about that. All right, so let's run through real briefly. So for the x-intercept, remember we set y equal to 0. So you have to be able to make a call of whether you think you can factor it or not, right? And if you can't factor it, what do you go to? Quadratic formula, but this one's pretty easily factorable, right? Aren't there some factors of 12 that would add up to negative 8? So they'd both need to be negative, and what would be the numbers? Minus 6, minus 2, right? So I end up, if I set both of these equal to 0, I end up getting x equals 6 and x equals 2. So my math lab's probably going to want these as points. So 6, 0 and 2, 0. The y-intercept, let's do f of 0. Notice the y-intercept is always going to be just whatever the constant is, because the 0 being plugged in for x is going to cancel everything else out. So this would be y equals 12, or the point 0, 12. I'm going to circle this because that's likely how my math lab is going to request the information. Vertex, and then we're going to graph it off to the side. So vertex, remember we want x equals negative b over 2a. So negative b would be positive 8 over 2 times 1. So we get 4 for the x part. And then we need to find the y part, right? So y is going to be f of 4. So 4 squared minus 8 times 4 plus 12. You get negative 4. I'm confident you could plug that in the calculator, so I moved a little quicker on the answer for that one. So what would the vertex be written as then? 4 comma negative 4. So here is what the graph would be. Now notice I'm going to make the graph kind of heavy on the top because I need to go up to a y-intercept of 12. And then I have x-intercepts of 2 and 6. Okay. If I had to pick a single most important point for you to get right in the parabola, it would be the vertex, because the vertex tells you where you're going to do what? It tells you where you're going to make a turn, right? So it's super, super important that you get the vertex right. In fact, if you get the vertex right, you can kind of make up for a lot of things that maybe aren't super perfect. But yeah, we're going to curve it, and notice it's a much kind of more narrow parabola just because it goes up so high. So we have no max, right? And the min is what? Negative 4. And then the last new thing I asked for was what is the range? But I think if we can look at the picture, we should be able to get that, right? Remember, range is the y values, right? So it's bottom to top. Okay, so what's the lowest y value we have? Negative 4. And then how high up do we go after that? Forever, right? To infinity. So it's negative 4, including 4, and then infinity. So that example 3 is probably a really good type of question that you might see on test 1, okay, where everything works out pretty pleasantly and all you have to do is be able to graph it, okay. Okay, so I'm going to be lazy. I'm going to say same instructions. But let's say that this is the x squared equation you get. So notice this is just in a little different format, right? It's still a parabola though. How do you know? Because what kind of power do I have? Squared, right? Anything squared is a parabola, okay? So let's just kind of go through it. Let's find the x-intercept first. Okay, so we would set 0 equal to the function we started with. Okay, so you could FOIL that out and then get your A, B, and C and do quadratic formula and all that mess, but you don't really have to do that. So let me show you an alternative here. We already have an equation equal to 0, so we can just kind of begin to kind of shift things around and solve for x, and maybe we can get the answer that way. So this would give us negative 2 equals negative parentheses x minus 3 squared. Remember, your goal is usually to get x by itself, or y if the problem involves y. So now let's get rid of the negative sign, which we could do by dividing by negative 1. So what am I going to get on the left there then? 2, right? Equals x minus 3 squared. So I'm sure it's been just a minute, right? But how do you undo a square? If I want to get x by itself, I need to get rid of that square. So what's the opposite of squaring something? Square rooting it. But just, it's easy to forget, and you need to try not to. When you do the square root method, which is what this is called, you have to remember that it's actually plus or minus the square root of 2. There's actually how many answers then? 2, right? Which we're used to that, right? We've been getting 2 answers. All right, so over on the left, we get plus or minus square root of 2. We'll mess with that in a minute. What about on the right? What was the point in us taking the square root of both sides? What does it do with the square? It cancels it out, right? And it just leaves x minus 3. But then we can just add 3 to both sides. So the left side, write the whole number first. So it's going to be 3 plus or minus the square root of 2. And then on the right, we just get x. Okay. So notice this is a solid answer, right? It may not be an answer we love because it's not a whole number, but this does represent 2 answers. So in other words, how many times is this graph going to cross the x-axis then? It's going to cross it twice. Okay. By the way, if you wanted to graph this, I don't know that we're going to have time to, but if we wanted to graph this, how would you figure out where to put your points? Like, I don't expect you to eyeball and wing that. Just use your calculator, right? Do 3 plus square root of 2, figure out that decimal, and then do 3 minus square root of 2 and figure out that decimal. Okay. All right, so let's go on to y-intercept. I'm going to do that over here. Since I'm not graphing, I don't need to leave this space free for that. So that's usually pretty easy, right? I just need to plug in 0 for the x, but I just need to be a little more cautious because of how this formula looks. So in other words, it's not maybe as quick or easy to eyeball this one, so we need to be a little careful. Which part of this should we be doing first? Yeah, well, before exponent is actually what? Parentheses first and then exponent, right? So do it in enough steps where you don't make a mistake, but the negative sign would stay, right? And then we would have negative 3 squared plus 2, okay? So now let's do exponents, right? So the negative 3 squared would be a 9, but the negative sign would still stay because the negative sign on the outside is really what I'm talking about, right? So we'd end up getting negative 7. So it would be the point 0, comma, negative 7. Okay, so just make sure you're cautious about your signs. The vertex, notice that, let's rewrite that formula. Notice this is actually in the other format that we haven't really done an example of yet. In other words, this is already in what we call vertex format. Okay, so to find the vertex, you just look at what the numbers are here and here when it looks like parentheses x minus a number squared and then plus or minus a number. So to find the vertex, you don't need to do any work. You actually just change the sign of this one and leave this one alone. Okay, so this would be just 3, 2. So remember, we said this back at the beginning of the notes, but you change the sign of x, but not y. And then last but not least, without graphing, let's see if we can figure out our max and min and then our range. There is, well, let me let you tell me that. What kind of opening are we going to have? So we don't need to multiply everything out. We just need to pay attention to the fact that there's a negative sign there, right? So it's going to open which direction? Downward, right? So there's going to be no what? No min, okay? And the max is going to be however high up the vertex is, right? So the max is just going to be 2. So if you can't visualize this, then you might need to actually sketch a graph. Okay, I just don't want to because of time, right? So if the peak is 2 and you picture an upside down parabola, what would the range be? Negative infinity, and then we're going to stop at that max of 2. Okay? So sometimes if maybe you're not requesting, or if they're not requesting that you graph it, you might not need to, okay? But if you need to, if you're a more visual learner and you just want to see what the graph looks like, you could always either graph it by hand, or remember you do have your graphing utility, okay? So, or a lot of you do anyway. Okay, so last example of the day, of the week, all that good stuff. So let's look at a little bit more at maybe some business applications. We're going to try to kind of do them as we go. Okay. So remember we talked about price I don't know when, I think it was last week, maybe the beginning of this week, but price is usually represented by a lowercase p as opposed to profit is usually uppercase P. But let's say your price equation is 75 minus 3x for some scenario, okay? Then if I want to find R of x, okay, which if we forgot that, what does R of x mean? What is capital R usually reserved for? Revenue. And just a kind of quick review, remember from the other day, revenue is the money that's brought in from the sale of however many items, okay? So revenue is found by taking two quantities. To find the revenue, you need two things. You need price and you need quantity. So think about like if you set up a lemonade stand when you were a kid, right? The way that you figure out how much money you bring in from that lemonade stand is you need to know how much are you charging for lemonade, right? How much are you making per cup? And then how many cups are you selling? Okay. And I bring up lemonade stand just because it's like the simplest business I can think of. Okay. So we have a price equation, right? What's the price equation that we were given? 75 minus 3x, right? And then the quantity is always just x. Okay. So in other words, in a price equation, the variable is always however many items you have. So if we do distributive property, so I'm going to rewrite this in another way just to make sure. I'm going to put the x first just because we're probably more comfortable with distributive property that looks like this rather than the x after. But we're going to get 75x minus 3x squared for the revenue. Or if we rewrite it, usually we write the x squared term first. All right, so with that equation, let's say that I asked you to find the max revenue. And something else. So the max revenue and how many items it takes to reach that max. So notice we have a quadratic equation. How do we know that? Because it's x squared, okay? And I'm being asked to find the max revenue, right? So we need to remember in the previous examples, what did the max always have a whole lot to do with? Like how did we find the max to begin with? We always looked at what piece? The vertex, right? So when you are asked to find the max, it's telling you to find the vertex. Okay. By the way, this is an upside down parabola, right? So the vertex would be the max as opposed to the min. So they're not holding your hand and telling you, but they're asking you to use the vertex formula. Okay. You just had to realize that max and vertex were kind of synonymous. All right, so let's figure that out. So it's going to be negative 75 over 2 times negative 3. So we end up getting a decimal here, and that's okay. I probably needed to state some parts of the problem first. Okay, so we got x equals 12.5. So up here, I was going to write it, but I thought I didn't have to, but now I see that I do. I should have defined this at the beginning, but x is millions of units. In other words, it's okay for us to get a decimal. Normally speaking, you wouldn't have half an item, right? But we're talking about millions of units. And also, let's say R of x is in millions. So that would have been something that I should have established at the beginning, but I'm establishing it now. So in other words, x is 12.5 million then, okay? And then how would I find the revenue at that quantity? Yeah, I just need to plug it in, right? I just need to find what R is, right? So I just need to find R of 12.5. So I would use my calculator for this, but I've got negative 3 times 12.5 squared plus 75 times 12.5. So let's use use our calculator to work that out. And then remember that I said that revenue was also in millions. So it's -3 times 12.5. Just trying to make that visible, but the lighting in this room is really kind of crappy. Squared, and then plus 75 times 12.5. And then notice we get 468.75. Okay, but since it's revenue, what do I need to remember? It's money, first of all, and that it's what? Millions. And it's definitely important that we write the millions, right? Because, I mean, like, the difference between $468 and $468.75 million is kind of a lot, okay? So notice, like, no matter what, even in word problem format, we're being asked to find one of the big components of the parabola, right? You're either being asked to find intercepts or, in this case, a vertex.
So on the homework, will you count it off if we don't put the dollar sign?
I think when you enter it in, I think it might already have the dollar sign for you. But I'm so like on a test or something, I might count off like a half a point or a point if you don't write the right like unit. I think on my math lab, generally speaking, I think they'll even do millions for you. So it'll be like dollar sign, they'll put a box in the middle, and then millions, and then you just have to fill in the blank. Okay, but just be aware that if it wasn't there, you would need to put it there. Okay. Okay, well, y'all have a great weekend. I will see y'all next week.